Hello, everyone. Welcome to another Milling Monday. My name is Phil Brown. Today, we're going to go over the Xometry test part, and we're going to run through creating cam toolpaths on this part so that you guys can get it ready to ship out to Xometry. So let's go ahead and jump into it. So what I'm going to first do is I'm going to switch design to manufacturer. I have uploaded this model, and then for the sake of everybody out there, I do have a cheat sheet here, and this cheat sheet is for me to be able to pay attention to a lot of these dimensions that aren't on the actual physical model. So with that being said, is the first thing I'm going to do is I'm going to create my setup. And from here, we're going to go ahead and set our stock size. Now, the call out for the stock size as a whole is, let's go ahead and see if that's on our drawing. I don't believe it is, but if I remember correctly per the website, it actually is a 3x1x2. Now, as you can see, my Fusion 360 actually automatically gave me that size. However, you can plug that information in here in real time. The trick, though, is always do your setup before your stock. And the reason for that is as soon as I pick my Z and set my X in this case, so I'm going to go ahead and create my X the long ways here. Now, if I go back to stock in this case, you're going to notice that the dimensions have automatically changed to accommodate keeping that rectangle around my part. Once you change these actual dimensions, though, it will kind of lock that in, which will throw you off. But again, as you can see, we have our 3, 2, 1. The only thing I'm going to adjust is my offset from top. And I'm going to go ahead and just move this up to 20. And as you can see, with that sitting at 20, we now have that ability to face off the top or clean up any material. However, here is something that I think I might actually do on my part, which is do the backside first so I can hit all of my outside edges, face off the back of my part, maybe tap, if not actually spot drill these holes on the backside, and get that all cleared up for the flip on the next op. So let's go ahead and do that. So I'm actually going to go back here and flip my Z. Now you can see I actually have my rectangle faced up. Again, that base is very square for me, so it's going to make it very easy to hold it in an op 2 scenario. So let's go ahead and hit OK. What I'm going to do from here is I'm going to go ahead and face off my part. So let's go ahead and go 2D face. I am going to use a lot of default tools here. So as you're going to see, I'm going to jump down to the Fusion library. And then from here, we're going to go to the face mill, and I'm going to use the 2-inch face mill. So normally, you're going to have a lot of different speeds and feeds in here. And this is where you guys are going to want to plug in your own speeds and feeds. We can click this edit tool. However, given this is a stainless part, maybe I don't run a lot of stainless. It's not a big deal. I can also modify those speeds and feeds over here on the right. So, for example, if you know your surface feet per minute is actually closer to 400, and then your feed rate per tooth is going to be, 10 thou, as I plug that in, you're going to notice that everything updates automatically right here. But keep in mind, this is now a custom speed and feed, and it doesn't push back to Fusion 360 library. Now, in our XY direction, everything else is going to come through just fine. We have a stock to recognize from our setup. We're going to machine down to our model top. Jumping over to our passes tab, as a precaution, I like to turn on multiple depths just in case there was more stock than that 20 that we left there. We're automatically going to find that. So as you're seeing, it is that easy to go in and create your initial cycle, which is going to face off the top of that part. Now, I'm going to go ahead and hit F8 on my keyboard. That's going to turn on my in-process stock, and I can now have an idea of going around the outside of this part. Now, for some of you, we could rough the outside of this part. I'm not actually going to rough the outside of this part, in my opinion. I'm just going to go straight for a finished 2D contour. We're going to go ahead and switch out my actual tooling. Let's go for a 1/2 inch flat. So again, as we're going to filter by flat end mills, we're going to go for that 1/2 inch flat. And then to show you guys, more speeds and feeds here, since this is stainless, we're going to go ahead and go down to stainless finishing. I'm going to select that speed and feed. And then from here, I'm going to go ahead and give it my actual geometry. So we're going to go ahead and pick that edge. My heights, so my Z-axis, we're actually not going to go to that selected edge. I'm actually going to tell the software I want to go to model bottom. And then I like to go past, probably about 20 thou. So I'm going to say -20. Taking a little further step over here. Again, we can actually do some roughing passes here inside of 2D contour. However, I may actually want to do this as all finishing passes. And now the cool thing here is if I set this to like 20, first time through, we're going to go ahead and hit OK. And what you're going to notice, it's going to make 20 passes, which is very overkill. However, again, Fusion is very intelligent with very little information. So if we give it a stock contour and now I hit OK, you're going to notice it's actually going to reduce that down to just knocking off the corners and then making 2 passes, even though we told it 20. So again, you could do a rough and then a finish. I think personally, since it's one part, you may actually make 2 of these in case you mess one up. It happens to the best of us. But I'm going to go ahead and just do a finishing toolpath and cut down on all this extra programming to really not save any time in the long run for this specific part. So now from here, let's go ahead and let's do our spot drilling. So I'm going to go into the drill profile. We're going to go ahead and select our spot drill. I do have in my shop crib a lovely little 3/8 here. Again, we could go down to our stainless speeds and feeds, or depending on what your speeds and feeds are set to. Again, we need to give it some geometry, so I'm going to go ahead and select a hole face here. And what you're going to notice is we're having a little bit of a tricky scenario where I can't pick that hole face, which is strange, but what could be happening here is these hole faces could not actually be square to my part profile. So I just want to verify this real quick by doing tool orientation. And then again, I can pick the hole surface. There it goes. It just was a little bug on my end. However, in most cases, guys, when you go to pick a whole surface, if you can't actually highlight that surface, odds are you're not actually square to that hole. So in a real world scenario, you guys kind of saw that. I just zoomed in and zoomed out a little bit and everything clicked into place. We're going to go ahead and select the same size diameter, meaning we're going to grab all of those. And then I'm actually going to do this hole at the same time. So what I'm going to do here is, again, we're going to go ahead and select that hole face. So I need to go back up. We don't need a containment boundary, guys. We need to make sure that we're selecting a hole face. And as you can see, I snatched up each and every one of those holes. Now, the trick here is, if you notice, we're going all the way to the bottom of that hole. So when we go into our Z heights, if I go down here where it says hole bottom, I may actually want to say, I want to go to a chamfer width or a chamfer diameter. Keep in mind, a chamfer width is going to be diameter plus width. Chamfer diameter is just going to be a hard diameter. So if I want to give all of these holes, maybe a 20 thou chamfer around the top, the moment I typed in that 20, you can see how it's going to sync my tool, that extra amount, in order to give me a 20 thou chamfer and break all those edges. Again, these are 440 holes here, so it may be a little bit different. Again, if I was deburring the backside of this, you may tumble this, you may hand deburr it, but I'm going to use my spot drill to my advantage to go ahead and hit those spots. So from here, I'm going to keep that spot drill though, and I'm actually going to break these edges on the backside of my part. And I'm going to do so by going down to 2D chamfer. So let's go ahead and pick that edge. Again, I have my selected contour, which is what I want to machine. And then I want to give this, maybe a 10 thou edge break. And again, we have a tip offset and then a clearance. We're not chamfering anything internal, so there's not a big worry there in Fusion. So we're going to go ahead and hit OK. And as you're going to see, I'm getting an issue here. And that issue is because my speeds and feeds were set to drilling, not finishing. So again, as you're going to see, we're going to go back and we're now going to give it finishing speeds and feeds, which shows us that there's a actual feed rate versus our drilling. When we go to drilling, this actually tends to be zeroed out. So again, we're going to go finishing and we're going to hit OK. And now we're breaking that edge all the way around the top. Now I'm going to show you a little trick here. So based on that through hole, that is a 313 through all. That's how it's called out. The actual smaller hole does not have excess precision to it. So another way I could do this is I'm going to change my chamfer first, and I'm going to add in this edge. And as you're going to see, we're now chamfering inside and out. I am going to remove that actual spot drill. So again, as I'm unselecting that hole face for my spot drill. And now with that being said, let's go in and bore that hole out. So again, I'm going to go 2D bore. We're going to go to a much smaller tool. I think I have a 1/4 inch flat in my library. That is a bull nose. So that does have a corner radius on the edge of it. And I'm going to go back to the Fusion library and just grab a flat end mill. We're going to go with that 1/4 inch flat. We are going to need a little bit of a 1/4 inch flat on the flip. Again, we're going to go with that, stainless steel roughing. Or actually, we can go finishing here because we are boring. And then from there, just like hole drilling, you just pick your profile. And as you're going to notice, we're now going in and boring out the inside of that hole. I may want to break this through the bottom, and I would prefer to, and I would suggest that for most of you, bring that through 20. So we're going to get down below this surface. Now, if you wanted to, you could actually bring that all the way through, which is something I would recommend. So we could actually say, let's go to a selected face and then still keep that 20th thou breakthrough. So as you can see, we're now breaking all the way down through that flat profile. Again, this is going to make our life easier when we do the counter bore, which is a precision hole on the flip. So again, you guys could actually turn on where if you wanted to. They're calling out, I think, plus or minus 5 on this whole drawing, which gives us tons of room to play with. Yep, plus or minus 5 on 3 decimal places. So really, my tool diameter in Fusion should be the same as what it is in the actual machine. So from here, you can now see we're boring out that hole, but we're actually doing all of our spot drilling and our chamfering before the bore. So this would actually probably get us in trouble, as you can see based on that stock. So what I'm going to do is I'm going to just drag my bore up, and I am going to place it in front of when we do our actual spot drilling and when we do our contouring. So as you can see there, I accidentally just placed it in the wrong spot. There's no reason to drag it up one space at a time, guys. But as you can see, we're now going to bore that hole. Then we're going to go in and we're going to place all of our spot drilling, and then we're going to add a chamfer. Now, you could chamfer first, you could spot drill first. It's not a big deal. And now, depending on the length of my tooling here, again, guys, I may actually drill these holes and tap them from the backside. And that's what I'm thinking I'm going to do here. So let's go ahead and do our drilling again. Little pro tip here is if I put my mouse on those holes we want to drill, you're going to see it's going to give me that diameter of 0.085. And that is actually the tap drill size for the 440 called out on my drawing right here in front of me. So what I'm going to do again is we're going to go ahead and get our 083. So let's go ahead and go back to the Fusion library. We're doing some drilling. Again, I arrange my stuff by diameter right here. Makes it a little easier to find stuff. And then I like to speed wheel my way down to see if I can find an 083. I do have an 082 right here, or an 086. So again, depending on your tap drill size, you're going to pick the correct size. Again, your speeds and feeds guys here. But we're going to go ahead and pick our hole. We're going to pick all the same size hole. And then here's where the tricky part is. Remember, we're doing the backside here first, so all this material underneath hasn't been cleared out. So we do have to be cautious of the idea that we need to drill deep enough that we have enough room for our tap to also go all the way through and clear. So by doing so, we are still going hole bottom because that gets us to the bottom of that plate and that surface. Now I want to go drill tip through, and now I am going to break through a decent amount. And the reason for that is again, depending on your tap, if you have a bottoming tap, a starting tap, we need to make sure that we have adequate room to go all the way down. Now, looking at this drilling cycle, we are getting into the world of possibly being, closer to 5 times deep. I'm going to go ahead and switch out to a chip breaking cycle. And what a chip breaking cycle is going to do is it's basically going to give me pecs. And it's going to get to a certain point where it's too deep. It's going to do a full retract and clear itself out. So a big difference between chip breaking and deep drilling retracts every time. Now, chip breaking will only retract at a maximum depth set, and then it will peck in between those cycles. So now that we've drilled that, let's go ahead and go back. We're going to now do drill again, and we're going to go ahead and grab our 440 tap. So back to my Fusion library, we're going to go ahead and grab a tap right-handed. Scroll down here a little bit, and there is our 440. Again, your speeds and feeds as always, guys. Same concept. We're going to go ahead and pick one hole. We're going to say select same size diameter. We're grabbing all of those. Of course, we want to go through the bottom, so I'm going to go ahead and check that drill tip through bottom, and then I'm going to give it my breakthrough amount. Let's say in my case, it's now 100 for this. So a really nifty trick here, in case you guys are wondering, as you can see, because everything is updating in real time, I can see how far my tap goes through, and I can also see that it's not actually bottoming out on my drilled hole, which can be very, very beneficial depending on who is operating that machine, or if this is your first time programming, this is something that will cause broken taps all day, every day. Again, if you're pushing that chip down versus pushing the chip out, we need to make sure we have room for that to clear inside of everything that we're doing. So now that we've done that, that kind of wraps up the first setup for this part. As you can see, I have this nice little hat here still to hold on to my part. We broke all the edges on this top face, making life extremely easy. Also, we could throw this in a tumbler after the fact and deburr it even more. And before I jump into setup 2, what I am going to tell you guys is, if you guys are liking this content, don't forget to catch our video on Turning Tuesday. We're actually going to do the lathe version of this part for Xometry. And as always, Leave comments down below, hit that like button, and subscribe if you want to continue to get notifications on content like this. So let's move into setup 2. So what I'm going to do is I'm going to go up to the top. We're going to go ahead and say a new setup. Again, I'm going to set my Z and my X. So this time we're going to go Z up. I do like X ran down my part. Now you can pick edges and faces here, guys. It's not a big deal. My stock, this is one thing I love with Fusion, is the fact that it's going to come from the preceding setup. And I'm going to turn on what's called continuous rest machining. So when I hit OK here, what you guys are going to see now is that stock, there is kind of that hueish color here, but you can see how that hat came through almost perfect for my second setup. So now I do know that I need to face off this part and get rid of that hat. So that's going to be the first thing I'm going to do. However, I'm going to cheat the system. I'm going to go ahead and grab that facing from up above. I'm going to right click copy, and then I'm going to come down to the second setup and I'm going to paste that. And what you're going to notice is upon pushing Control G to regenerate, my facing cycle just came through and faced off that entire hat for me nice and easily. So now from here, I have a nice square block with that little pyramid fixture. So let's start to rough everything out. So what I'm going to do is go to 3D Adaptive Clearing, and we're going to go ahead and go back and grab our 1/2" tool that we've been using. Again, grabbing our speeds and feeds down below, of course. And from here, this is what I like about 3D versus working with anything in the world of 2D, is the fact that we are model aware inside of Fusion 360. So what you're going to see happen here is when we go to our passes tab, we have our step over, it's referred to optimal load. We also have what's called a maximum step down, a minimum step down, and then flat area detection. And how that's going to actually work is we're going to go to a max of 0.75, and then we're going to work back upwards in basically increments of 0.75. Now, if we encounter a flat, as we may here or may inside of our counterbore, we're now going to have a even closer accuracy to those flats. So instead of being within 0.75 of a flat, we're now going to be within this number here, which I assume is like 0.00075, because it is very accurate. You guys can fine tune this. So again, we do want to leave material, and the reason for leaving material is going to allow us to come back and clean that up. And now, as you guys can see, as I said, is we're going to go 75 deep, and then we're going to go 0.75 up, which is what is happening on these pyramid areas. And then down here at the bottom, we are making a second pass, which tells me we're greater than 750, but we're not quite 0.75 different, which means we're going to make one pass for flat area detection. Now, I could tweak this a little bit, increase my step down, decrease my step down, things like that. But I'm just showing you guys where the stuff is and how to get some paths on this part to get to this point. So as you can see here, we also didn't do anything in our counterbore, which is perfect. However, we also didn't squeeze our tool in between these islands here to be able to actually split those apart. So let's go ahead and start to take care of some of that stuff. So the first thing I'm personally going to do, and this is my opinion on it, is the outside of my part is all finished, right? Now, I need to start to clean up the inside areas, and before I actually switch my tool out to that 1/4" tool to squeeze in here, I'm actually going to stay with that 1/2" and do whatever I can with that 1/2" prior to. So let's go ahead and go back. I'm going to go ahead and pull a measurement here and see what the size is here. So as we can see, that's 475. So what I'm going to need to do is do that with the 1/4". That's fine. But I'm going to go 2D contour, and now holding the Alt key, I'm going to go ahead and select this edge. And then I'm going to hold my Alt key, and I'm going to select this edge over here. Now, what we want to do is we want to modify these, but we know this is a perfectly straight edge. Could I select this edge and then this edge in 2 separate segments? Yes. But one thing you could also do is we could edit this edge, and we could actually say we want our start point to start 0.25 back. And as you're seeing, that extended out both the start and the finish. But now my end extension, I want that to be closer to like 1.5. And now as you notice, I've extended that all the way out past my part. So here's an example where I'm just using a simple edge to create that whole profile and go across the part. Now to show you the comparison of these two, I'm actually going to go ahead and add 2 segments here versus 1 segment and an extension to show you what's going to happen. So as you can see, again, we can get rid of this retract here, but I'm coming in, I'm backing out. I'm coming in and I'm backing out versus one nice, super clean swipe across my part. One other thing that you noticed is we actually didn't finish our floors up yet, which we may want to do that, which is causing that actual ugly step down in our part because we failed to actually clean up the floor on this part. So let's go ahead and fix this real quick, and let's do a floor cleaning cycle. So I'm going to go back to my geometry tab. We're going to go ahead and close that. I'm going to edit this guy here. Again, we're starting 250 off, and we're going 1.5 past. And again, as soon as I hit OK, you guys are going to see how we are now coming all the way across that with one clean motion. Now, I don't like this retract in here, so let's fix that real quick. So again, as if I go to my linking tab, and a little pro tip here for you guys, if you notice the colors, yellow and green are kind of your lead in and lead out motions. So it's always going to be something you're going to adjust in your linking tab. So again, this is orange, red, everything but your blue lines, basically. So I can come in here and I can say, keep that tool down. And now I really don't need to do a vertical lead-in radius at all. So I'm going to go ahead and zero that out. And what you're going to notice now is we come straight to depth, we lead in, we straight across, we lead in, and then we lead out. No vertical lead-ins, no funky moves. But like I said, there's a lot of ways for you guys to achieve what you're doing here. I'm just programming this off to just make it as simple as possible for you guys to get a good fresh start and learn some things in Fusion. So let's do that floor cycle. So I have a lot of different cycles here we could do. We could do everything from flat. And again, is an easy way if you guys are experimenting with new toolpaths and you don't know what you're doing, is to grab a toolpath and hit OK and see what it gives you. So as you're seeing here, is flat actually works very good. However, it is going full width across my part, so I have to be conscious about that. And we're also doing a little dipping in out here on the outside. Now, we could also do what's called a horizontal toolpath. So let's go ahead and grab that horizontal toolpath. Again, hitting OK. Don't mind this stuff up at the top. It's not a big deal. But as you're seeing is, again, we're staying on our part on the inside. Again, we're coming in over here, and we're coming straight in, doing our center section, and then working our way out. Now, whatever way you want to choose, that's up to you. But one thing I am going to want to do is I'm going to want to make sure that things as such is I don't really need to start all the way at the stock top. I may actually say start at the top face here, and maybe I bring that up just a hair, or I leave it right where it is. But as you're going to see, I've now eliminated that upper section because I'm filtering in Z now. Again, we go back to that flat toolpath. I can make some changes here to avoid outside areas. Again, I don't personally think one is right or wrong, and this is up to you which one you choose. But I do want you to know you always want to come in, and when you're making these passes, you want to make sure you leave stock on the walls, and you always want to leave more stock on the walls than you did when you actually are doing your finishing pass after for the walls, because we don't want to rub that wall and cause any surface defects. So I'm actually leaving radial stock, and then I'm leaving nothing on the axial. So as you're seeing here is what's happening is we're allowing that toolpath to come in, and I'm going to go ahead and reorder this real quick so you guys can see this. So I'm going to stick with the flat toolpath, so let me delete my horizontal. But if we look at the actual stock recognition here, and let me get my mouse out of the way, you're going to notice that there's this lovely little step happening in here. And that great purpose of that step is that we've roughed everything down to this point. We left 20 on the walls, right? And here's my model in here for you guys to see. Now, I'm leaving 25 here to guarantee when we do the floor that I don't touch the walls. And then we come through and we clean up those walls, as you can see here, and we knock that all down to a finished surface. So this is working out really well for everything we're doing. We're sticking with a very large tool to make this happen, and so that we don't have any issues. So now let's actually split these pyramids in half. So again, I'm going to go for a 2D contour as a little bit more of an experienced user. I'm going to hold my Alt key here, and I'm going to pick my two edges. Again, I'm going to go over here. I'm going to hold my Alt key, and I'm going to pick my two edges. And then what I'm going to do a little differently is after I select my 1/4 inch flat, don't forget to set your speeds and feeds, guys. I'm going to go to my passes tab, and we're going to make multiple depths in here. And let's just say I'm going to go 250 deep because it's, 1 times diameter depth of cuts. So what you're going to notice now is we're going in and we're splitting apart that actual area. However, again, just like before, we want to do a tangential extension to make sure we're starting off that area and feeding into it. We're not plunging down on it. However, when we go into 2D contour, and I'm going to go to my passes tab, we actually have the ability to do a tangential extension to everything. So instead of individualizing it in the actual chaining tab, we're going to actually do it all right here. So I'm going to go ahead and throw a 0.125, half the diameter of my tool in here real quick. We're going to go ahead and hit OK. And now you're seeing we're coming down and across each and every time. We are doing full retract still. And if you guys remember, we did do this before where we went in. We said, no, keep the tool down. There's no reason to retract. And now you can see we're just coming in and out. We still do have that little bit of a vertical lead in, but you guys could zero that out as well to speed up that cycle time as much as possible. So you could also do multiple passes here, guys. There's a lot of ways to clean that up, but as you're seeing is I'm actually just scraping out everything in there and cleaning that all up just to open it up as per the drawing and the model shows. So let's attack our bore now. So again, I'm going to go in, I'm going to say 2D bore. Now it's up to you if you go bore here, guys, or if you just go straight 2D contour, because the center is open on this. So you don't necessarily need to bore down. This is just muscle memory, and what I know has worked out very well for me over the years is I can just say, go in, bore that profile with that 1/4 inch tool, and I'm going to get what I want, and it's going to work out great. Again, you could come in on center, swing around. Also, this is just what I like to do. So let's go back now, and since we have our drilled and tapped holes, we've actually bored this out. We could go in and actually deburr some of these edges or chamfer these edges again. So let's get our 2D chamfer tool going. Again, I'm going to pick the edges that I want to chamfer. Again, I'm going to set my chamfer width. Let's go ahead and say this is 10, not 100. That'd be a little overkill. I'm also actually going to grab a couple of these edges in here too and see if we can get all of this stuff done in one shot, or if I can't. So one thing you're going to notice is Fusion is going to avoid areas. I am going to get a warning here, and that warning is telling me that certain modeled areas our tool could not actually clear to get in there. So keep in mind, this is the cool thing about that chamfer clearance is we are staying away from these corners so that we actually don't cause any problems there. So again, we do that drilling. We're going to go ahead and say we're going to pick our faces that we want to drill. Again, there was a little bit of that bug there. As you guys saw, I had to zoom in for it to give me that face, but it's not a big deal. Again, we're not going to drill tip through bottom. We're just going to say 2 chamfer width. If I remember correctly, I think we threw 20 at it last time. And just like that, we're not spot drilling all those backsides and deburring those edges. Again, this is the cool thing with Fusion's physical representation of what you're doing, is if I turn my model off, you could actually see that diameter right now is the maximum size of my tap. And then you can see we have a little bit more there. So I got really lucky with estimating and guessing what's capable. One other thing that I am noticing though, is we're not actually chamfering the inside of this hole. Now, the reason why we're not chamfering in here is because our tip offset isn't great enough to get down in here, or it's too great where the shoulder of that tool is hitting our chamfer up here. Again, these are things to keep in mind depending on what you're doing or how you're doing it. I could, as always, come back in here, add this into when we do our spot drilling, and just like that, I'm now hitting that lower profile again and busting that edge. So let's get into the 3D of these actual pyramid surfaces. Now, some of you could stand this up by all means on its side, and you could machine it from the side. However, they've given us a lot of room to actually get in here with a 1/4 inch ball and go all the way up and over and 3D this actual profile here. Yes, it's going to take a little bit more time, but as I always tell people, do you want to spend 30 minutes running it on the machine, or do you want to spend 30 minutes programming it? There's a lot of lenience on both sides that's going to work better for you. If I ran 100 of these, by all means, I would hope I have a 4th axis or a 5 axis, allowing me to tilt it and just machine it. But since we're working in a 3-axis machine, we're just going to go back and say, let's do a 3D contour. Let's swap out for a 1/4 inch ball. So we're going to go ahead and go to our ball end mill. We're going to grab that 1/4 inch ball. Again, as you guys know, grab your speeds and feeds. We're going to jump over to our geometry, and we're actually going to select what we want to machine. So what I want to machine is this area around that fillet and everything. But what you're noticing is depending on where I put my mouse, I'm getting kind of a weird chain. Even holding the Alt key and selecting is a little tricky here because as you're seeing is it gave me the edges, but it gave me everything down and around in a funky fashion. I, for example purposes, just click this chain again, and I am going to bring it all the way up and around to kind of show you what I want to do, and that's why I've selected it. But when I still hit OK, it snaps down to the bottom. It's not a big deal, guys. So again, I'm going to do one of these to test it, and then I'm going to add the other 3 in as needed. So again, as we're going to go over to our passes tab, I'm going to give this a much smaller step down of about 10 thou. Again, we're going to go ahead and make sure that we have everything set. We're going to hit OK and see what we get here. So as you see, we're actually coming all the way up the top, and we are starting to see that that 3D is working, but we are having a dilemma. And that dilemma is we're not getting this upper corner, and for some reason, we're not getting this lower corner, right? And the reason why that is happening is because if we go back to our containment, we have told it to keep the center tool of that containment. So if we actually square up to this, you're going to notice that the very tip of the tool actually sits here, which is vertical right over the containment. Now, what I want to do is I want that tool tip to actually go past this and come down over here where the actual edge of the tool is touching. And how I do so is by turning on what's called contact point boundary. Contact point boundary is exactly that. It shifts from center line to center of where that radius is engaging with my part. So if I go ahead and hit OK again, what we're going to see now is we're actually coming all the way over the top, and we're coming all the way down this face here. So again, as if we look at this in a couple of different views, you're going to notice that we're 3Ding that all the way up and over. Now, there is a lot of ways for you guys to do this specific profile. You could have also done this with a parallel, right? We could have used a parallel toolpath to go up and over. A neat trick is again, when you guys are experimenting with this stuff, if I right-click the path that I have and I go through, I can actually do what's called a derive. And what a derive allows me to do is to bring that information of like contact point boundary, boundary selected, all that stuff through in real time. Now, with this actual parallel toolpath, we can define a direction. So I'm going to use this little edge here. And then again, let's just give it, 10,000 step overs. And what you're going to notice with the parallel path, we're now running up and down across that profile. Again, this could give you a dramatically better finish. So there's nothing wrong with doing, maybe a pre-finish with this path into a post-finish with this path. But as you can see, neither one is necessarily right or wrong. We're more concerned about surface finish and accuracy, and both of these paths are going to get you there. So let's go back, and I'm just going to take my 2D contour. We're going to add in those couple of extra profiles. Again, what you guys are seeing me do here is I'm picking one edge, and it's actually giving me the full corner as we wanted. We could go ahead and hit OK, and just like that, we are now 3Ding those slopes. Now, if I needed a better surface finish or worse surface finish, I can adjust my step down, everything and anything here. You could also use a bowl end mill, which is a corner radius flat. I just picked a ball, very simple to do with. So now that we've done that, we could actually go ahead and let's simulate this guy out real quick and take a look at it. So we're going to go ahead and hit simulate. I know we didn't simulate the first half. You guys can simulate that obviously before you run it. As we're seeing in real time how our tools are going to act, what's going to happen as we go through and machine this. And this is very, very beneficial for you guys to make sure that you're not having any collisions or any problems with your machining. And from there, we're not hitting any holders. If I had my vise and everything else in here, that vise would show up, of course. Make sure we're not hitting the vise. And that might be one thing you got to be a little cautious about which way you hold this part. But overall, this actually looks exceptionally well. And before I actually wrap up this video, I'm going to do one more toolpath. And now this is a machining extension toolpath. However, what you're going to notice is it does give me the ability to 3D deburr and break edges. And that's what I absolutely love about the deburr toolpath. I actually did a Fusion Friday, last Friday video on it, and you guys are welcome to go check that out. But as you're going to see, if I grab that tool, and I'm going to go ahead and say 10,000 edge break everywhere, right? And I hit OK, it's actually going to go up, down, and around all of these edges anywhere and everywhere where it can engage. Now, another thing that this thing can actually do is we can make a couple of quick modifications. So again, I'm going to go to my passes tab, and I'm going to say cut with tip of tool. And what that's going to allow us to do is get even closer into these corners and try to get everything deburred as much as possible. Again, breaking these edges for anybody that's going to handle this part or having to turn this over to Xometry, of course. It even gets our vertical edges. So if you want to see more content on that actual deburr toolpath, check out my Fusion Friday video where we dive a little deeper. I'm going to go ahead and remove it. So at this point, if you are new to Fusion, we would go ahead and post-process this out. I'm going to post-process the whole setup. We're going to go ahead and right-click Post. We are going to have to pick our post-processor. So depending on your machine, we're going to go ahead and grab our post. We're going to hit Post, and then you're going to have your G-code to go run. Now, another little tip here, guys, is if you don't like where your work offset is, again, you can move that at any time. Maybe on Op 2, I want to use the model box point. And what I'm going to do is I'm going to use bottom back left corner. And the reason why I'm going to do that is because that's my fixed jaw. My stop is over here on the left, so we can align that and hold on to it. But again, this is just little things in your workflow to make your life much easier. As always, guys, have a great rest of your day. And before I go, I always have to say it. It's not what you know, it's who you know. And you all know me, Phil Brown, over here at JIT CAD/CAM. And we offer everything from custom one-on-one training to contract programming and even selling and deploying of the Fusion 360 software to get you guys going as fast as possible. And if you'd like more info about that, feel free to reach out to me with the link below at our website as well. Always have that great day. Get after it. I know it's Monday, and if you're like me, you probably need to drink more coffee already, and that's how I'm feeling.